Welcome to the Crazy Alchemist podcast, where alchemy, occultism, and strange history come alive.
In 1982, a surgeon in California opened a patient's chest with a scalpel made of volcanic glass. The blade had been pressure-flaked by hand in Idaho by an archaeologist named Don Crabtree, who had rediscovered the technique the Aztecs used in the 16th century. Crabtree himself had already lain on an operating table and been cut open with knives he had napped from obsidian. The blades worked, the healing went normally, and the edge, measured under an electron microscope, was about 10 to 30 times sharper than anything medical steel could produce. Obsidian is what happens when lava cools too fast to crystallize. A rhyolitic melt hits open air, loses its water, and freezes in place as a dark, natural glass. It is chemically almost identical to the glass in your window, but far older than any furnace, a geological accident that produces, by sheer chance, the sharpest edge in the natural world. Humans noticed this quickly. The oldest manufactured mirrors on Earth are obsidian discs from central Anatolia, polished in the 7th millennium before Christ. The Aztecs built an empire on obsidian blades and named one of their highest gods after a smoking obsidian mirror. A black obsidian disc now sitting in the British Museum was traced in 2021 to the Aztec mines at Pachuca, and an 18th century label on its case claims it belonged to the Elizabethan magus John Dee. Modern heart surgeons have opened incisions with obsidian because no steel scalpel can match the edge. 9,000 years, 3 continents, one material that kept reappearing wherever people tried to cut between worlds. Let's start with what the rock actually is. Obsidian forms only under narrow conditions. The lava must be high in silica, around 70 to 75%, which makes it viscous and slow to flow. It must cool fast enough that crystals cannot nucleate. It must lose its dissolved water at the surface, or later eruptions will foam it into pumice. The result is an amorphous solid with the chemistry of granite and the fracture pattern of glass. That fracture pattern is the whole story. Because obsidian has no crystal lattice to interrupt a break, a well-aimed strike propagates what geologists call a conchoidal fracture, a smooth, curved surface with no ragged edges. Steel and flint both break along grain boundaries. Obsidian has no grain boundaries. Under a scanning electron microscope, a honed steel scalpel edge looks like a ridge of peaks. An obsidian edge looks like a clean slope that narrows until it vanishes. It is not indestructible. Obsidian rates about 5 on the Mohs scale and chips if you hit it wrong. It slowly crystallizes into a dull rock called pearlite over geological time, which is why almost no obsidian older than 20 million years survives on Earth. But on the human time scale, a well-made blade holds its edge for decades. The color depends on microscopic inclusions. Black obsidian carries nanoscale magnetite, red or mahogany streaks come from hematite. The rare green-gold obsidian of Sierra de Pachuca in central Mexico is translucent and was prized above all others by the Aztecs. Snowflake obsidian carries small white spherulites of cristobalite, a high-temperature form of silica that nucleated during slow cooling. Now, the oldest mirrors. In 1961, the British archaeologist James Mellart opened a Neolithic mound in south-central Anatolia called Çatalhöyük. Over 4 seasons of excavation, he exposed a dense agglomeration of mud brick houses, burials beneath the floors, bulls' heads mounted on walls, and a body of material culture dated to the 7th and early 6th millennia before Christ. Among the grave goods were small polished discs of obsidian. Melart published 6 of them. A later inventory listed 11 candidates, and in the year 2000, a flint knapper named James Vetter, working experimentally, verified 8 of those as genuine mirrors. 3 sit today in the Museum of Anatolian Civilizations in Ankara. 3 more are in the Archaeological Museum of Konya. They are circular, slightly convex, and still polished to the point where they reflect a face. Recent work has expanded the picture. A 2025 synthesis by the French archaeologist Alice Vinet counts 56 obsidian mirrors across the Neolithic Near East, distributed among 6 Anatolian sites, plus 1 example from Tel Kabri in the southern Levant. The manufacturing center appears to have been not Çatalhöyük itself, but a smaller site called Tepecik in the Melendez Plain of Cappadocia, where the preforms and the full reduction sequence have been found. Çatalhöyük seems to have received finished mirrors from there. What these objects meant is harder to pin down. They are not cosmetic accessories in any simple sense. Most come from graves or ritual deposits. Their reflective surfaces are slightly convex, which produces a compressed and darkened image rather than a clear reproduction of the face. Modern reproductions by Vetter show the original optics, a dim, monochrome reflection, dark enough to be useful for scrying, but too distorted for vanity. The bigger claim that usually follows, the oldest mirrors in human history, is defensible if you read it carefully. People must have looked at still water and polished shell far earlier, but the earliest intentionally manufactured reflective objects in the archaeological record are these Anatolian obsidian discs. Copper mirrors do not appear in Mesopotamia and Egypt until the late 4th millennium before Christ, and standardized bronze mirrors in Egypt only from around 2000 before Christ. For roughly 3,000 years, if you wanted to see your face in anything other than water, you were looking into volcanic glass. Which raises the question of how that volcanic glass was getting around. In 1964, Colin Renfrew, J.E. Dixon, and J.R. Cann published the first of 2 papers that changed how archaeologists thought about exchange. They took obsidian samples from Near Eastern Neolithic sites and traced each one back to its geological source by trace element chemistry. The results were surprising. Cappadocian obsidian from Gulu Daw turned up at Jericho, 700 to 1,000 kilometers from the source as early as the pre-pottery Neolithic. Armenian obsidian reached down into northern Mesopotamia. Obsidian from the island of Milos in the Aegean ended up on the Greek mainland and in the Peloponnese. The concentration dropped smoothly with distance, which Renfrew modeled as down-the-line exchange. Each community kept most of what came in, passed a fraction further along, and the signal faded as a predictable function of kilometers from the quarry. This was long-distance trade before the wheel, before coinage, before writing. It operated on the basis of volcanic glass moving from hand to hand across mountains and deserts, and it operated consistently enough that modern statistics can recover its shape from the dust. At sites 700 kilometers from the nearest outcrop, obsidian still accounted for about 0.5% of chipped stone, small but never zero. The same story repeats on other continents. In the Mediterranean, obsidian from the island of Lipari reached over 200 sites across the central basin. In Japan, obsidian from Kozushima was being moved by watercraft in the Upper Paleolithic, one of the earliest pieces of evidence for seafaring anywhere on Earth. In East Africa, Kenyan and Ethiopian Rift Valley sources fed exchange networks that archaeology is still mapping. Pachuca obsidian from central Mexico reached the Maya lowlands at Tikal and Chichen Itza, and small amounts even turned up in the American Southwest, possibly carried by the Mexican Indian allies of the Coronado expedition in 1540. People carried this stone because nothing else cut like it. They also carried it in some places because nothing else reflected like it. By the time the Spanish arrived in 1519, the Aztec state had organized obsidian production on a scale nothing in the Old World matched. The main source was Sierra de las Navajas, the Mountain of Knives, a ridge of Pachuca obsidian about 85 kilometers northeast of modern Mexico City. The archaeologist Alejandro Pastrana has estimated an Aztec period workforce in the hundreds of miners and knappers at peak production. They reduced nodules to polyhedral cores from which pressure-flaked prismatic blades could be struck in long standardized series. A prismatic blade is a specialized form. Starting from a carefully prepared core, a skilled knapper uses a chest crutch to apply long, controlled pressure along a vertical edge. A blade detaches as a nearly perfect parallelepiped. Each core yields many blades. The edges come off the fracture directly and never need grinding. Don Crabtree, the same archaeologist who would later be cut open with his own blades, reconstructed the technique experimentally in the 1960s. His work showed that the Mesoamerican blade makers were operating within a technology as precise as any metallurgical industry of their century. The blades became razors, sacrificial knives, inserts for the Macoitl war club, surgical tools, and cutting edges for everyday craft. A 2025 compositional study published in the Proceedings of the National Academy of Sciences used portable X-ray fluorescence on 788 obsidian artifacts from Templo Mayer offerings. Of these, 702, about 89%, came from Pachuca. The rest came from Otumba, Paredon, Ucareo, Tulancingo, and a scatter of other sources. The pattern shifted over time. Early in the empire, the secondary sources dominated. After imperial consolidation around 1430, the pattern changed, with Ucareo obsidian from Tarascan territory reaching the Aztec ritual core despite the two states being enemies. The ritual core is where the interesting part happens. The Aztecs did not call their chief sorcerer-god by a name about darkness or cunning. They called him Tezcatlipoca, which is Nahuatl for smoking mirror. The name is literal. Tezcat means mirror, poca means to smoke. Across the codices, he is depicted missing his right foot, replaced by an obsidian disc. One myth explains it as a wound from his battle with the earth monster Cipactli during the creation of the world. The obsidian at the ankle marks the place where the god touches the other side. Tezcatlipoca was the patron of kings, sorcerers, and slaves. His priests used obsidian mirrors for divination, and here is the detail that ties the whole thing together. The Nahuatl verb for to prophesy, itzpopolhuya, is built from itztli, the word for obsidian, and popolhuya, to cast a spell. At the level of language itself, prophecy and volcanic glass were the same thing. In the Toltec cycle, preserved by the Franciscan chronicler Bernardino de Sahagún in the Florentine Codex, Tezcatlipoca destroys his rival Quetzalcoatl by showing him his aged face in a mirror. Quetzalcoatl had never seen himself. The shock drives him into exile. The god of wind and feathered creation is undone by a reflection in polished stone. Which brings us to the strangest object in the British Museum. In 1966, the museum paid £750 to a Reverend Robert William Stannard for a circular, polished obsidian disc about 18.5 centimeters across, mounted with a short perforated handle and housed in a tooled leather case. Inside the case, pasted against the lid, is a paper label written by Horace Walpole. The label reads, "The black stone into which Dr. Dee used to call his spirits." A longer version adds that the stone passed from the Earls of Peterborough to Lady Elizabeth Germain and came to Walpole around 1771 as a gift from Lord Frederick Campbell, who had bought it at the Germain sale. Walpole also copied out a couplet from Samuel Butler's satirical poem Hudibrash onto the same case. Kelly did all his feats upon the devil's looking-glass, a stone. John Dee was the Elizabethan mathematician, astrologer, and court scholar who served Queen Elizabeth I, advised on the reform of the calendar, owned the largest private library in England, and spent the last 25 years of his life trying to converse with angels. His principal scryer, Edward Kelly, joined him on the 10th of March 1582 at Dee's house in Mortlake. Together, they produced the angelic diaries preserved today at the British Library, including the Enochian alphabet that Western occultism has been recycling ever since. The partnership ended in 1587 after a scandal involving a revelation from an angel named Medimi that the two men should exchange wives. Dee described his scrying tools in his own writing. He referred to them as the stone, the shoe stone, the angelical stone, and the principal stone. He mentioned crystals and shoe stones. He did not describe a black Mexican disc. In 2021, Stuart Campbell of the University of Manchester, working with a team including Elizabeth Healy and Michael Glasscock at the Missouri Research Reactor, published a portable X-ray fluorescence study in the journal Antiquity. The team analyzed 4 Mexican-style obsidian objects in the British Museum, including the disc from the Walpole case. The result for Dee's mirror was unambiguous. The obsidian came from Pachuca. 2 of the other objects matched Pachuca as well. A 4th matched the source at Eucario. The disc is Aztec, made somewhere in central Mexico before 1521, and it reached Europe by an undocumented route during the flood of New World curiosities that followed the Spanish conquest. This much is solid. The problem is that Aztec obsidian mirrors reaching 16th century Europe is not the same question as whether John Dee personally scried into this particular one. 2 senior British Museum curators, Silke Ackerman and Louise Devoy, published a careful review in 2012 and concluded, "A direct link between these objects and Dee remains to be proven. The attribution rests on Walpole's 18th century label and the collector tradition behind it. The Peterborough catalogue entry that Walpole cites has not been independently located. Between 1521 and the mid-17th century, the disc has no documented owner at all." This is where the story wants to collapse into 2 answers. The skeptic says the mirror is a romance, a piece of Aztec ritual equipment misattributed to a famous magus by an 18th century antiquarian with a taste for Gothic curiosities. The enthusiast says the provenance chain, though broken, is still a chain, and that Dee's known curiosity about continental cabinets of wonders makes it plausible he encountered Mesoamerican mirrors during his years at the court of Rudolf II in Prague. Both positions close the question before the evidence has finished speaking. The object is Aztec. It is from Pachuca. Someone in Walpole's 18th century milieu thought it was Dee's. Whether Dee ever touched it remains an open question. The honest answer is that the mirror is a genuine Aztec ritual object with an unproven Elizabethan afterlife, and the ambiguity is not going to be resolved by another X-ray pass. It needs a 16th century document that has not yet surfaced. The interesting part is that neither reading changes what the object was designed to do. An Aztec obsidian mirror is a Tezcatlipoca mirror, whether or not an Englishman later used it. It was made to reflect a darkened image back at a priest who was looking for something the clear light of day did not show. Dee's angelic conversations were, in structure, the same activity under a different theology. If the mirror crossed the Atlantic and ended up in Mortlake, it moved from one scrying tradition to another without changing function. Which brings us back to the scalpel. In March 1982, the Western Journal of Medicine published a short paper by Bruce A. Buck, a physician with an amateur interest in flint knapping. The title was Ancient Technology in Contemporary Surgery. Buck had taken obsidian blades knapped by Don Crabtree and honed steel scalpels, and he photographed both under a scanning electron microscope. The steel edge, at high magnification, looked like a mountain range. The obsidian edge looked clean. Buck measured the obsidian apex at roughly 30 angstroms, or about 3 nanometers. That figure is the source of nearly every subsequent claim about obsidian's sharpness. It has not been independently replicated in a modern peer-reviewed study, but the physics is consistent with what we know about conchoidal fracture in amorphous glass. Steel scalpels, by contrast, terminate at an apex width of around 50 to 100 nanometers, limited by the crystal grain size of the alloy. The honest ratio is therefore roughly 10 to 30 times sharper, enough to matter for tissue damage, but not the hundreds of times or one molecule thick claim that often circulates online. The stone is sharper than the scalpel, just not by magic. Don Crabtree himself, who had rediscovered Aztec prismatic blade technique in his Idaho workshop, had obsidian blades used during his own cancer surgery in the 1970s. His chest was cut open with knives he had knapped from volcanic glass. The exact date and the attending surgeon are not well documented in the peer-reviewed record, but the blades worked and the healing went normally. In 1993, Joseph Dissa and colleagues ran a controlled comparison in rats, published in the journal Plastic and Reconstructive Surgery. 40 rats received paired 8-centimeter incisions on the back, one with a steel scalpel and one with obsidian. At 7, 10, and 14 days, the obsidian wounds showed significantly narrower scars, with fewer inflammatory cells and less granulation tissue. By day 21, the difference had disappeared. The early cosmetic advantage was real. The long-term outcome was the same. A handful of surgeons have used obsidian scalpels in specific clinical contexts. Dr. Lee Green at the University of Alberta is the most public advocate. Eric Callahan, a flint knapper with a doctorate in archaeology, supplied blades for operations at the University of Michigan in the early 1980s. The blades are not FDA approved for general human surgery, for 2 reasons. They are brittle, and lateral force can fracture them and leave fragments in tissue. They cannot be manufactured to lot uniform standards because every blade is pressure flaked by hand. Each one is slightly different. The strange part is that those limitations are exactly the reason the original Aztec blade makers knapped them by the thousand. A prismatic blade is cheap if your raw material is a mountain of volcanic glass and your labor is a cast of specialized priests and knappers. A uniform industrial product is expensive if your raw material is steel and your labor has to be retrained. The ancient technology was not primitive. It was optimized for a different economy. A surgeon opening a cornea with a knapped obsidian blade in 1982 was doing, with modern sterilization and microscopy, what an Aztec napper at Sierra de las Navajas was doing in 1520. The only thing that had changed was who held the stone. So what do we make of all this? 1 material, 3 cuts. Volcanic glass combines properties that almost nothing else in nature combines. It takes the finest edge in the natural world. It holds a polish dark enough to darken a reflection without losing it. It is found in concentrated deposits that a walking person can reach and carry from Anatolia to Mexico to Japan to East Africa. Everywhere humans have encountered it, they have used it for cutting, for seeing into what lies on the other side, and as a gift to bury with the dead. The convergence is not mysterious in the usual sense. Obsidian works because of its atomic structure, and atomic structure is the same on both sides of the Atlantic. The second step is the striking one. Different cultures took the same material and arrived at the same ritual uses without contact. Tezcatlipoca's obsidian foot and a Çatalhöyük burial mirror are separated by 9,000 years and half the globe. Both put polished volcanic glass at the boundary between a person and what lies beyond. John Dee's scrying sessions at Mortlake were looking for angels. The Aztec priests at Templo Mayor were looking for Tezcatlipoca. A Neolithic farmer buried under the floor at Çatalhöyük was taken into the earth with a mirror at her side, and the reason we do not know her thoughts is that she is not available to tell us. The surface of the stone has not changed in any of these cases, only the expectations we bring to it have shifted. Modern material science has its own version of the mystery. Put a cornea under a good microscope and an obsidian blade cuts along cell boundaries instead of shearing through them. A steel blade separates tissue by breaking it. A knapped edge separates tissue by finding the seams already there. In that narrow physical sense, the old idea that obsidian opens a passage where none was visible before is not completely wrong. It just does not need angels to explain it. The mountain still stands. The Aztec knappers are gone, but obsidian, which started as the fastest accident in volcanism and ended in an operating room in Alberta, keeps doing what it has done since the first hand picked up the first flake of it. It makes a cut. Whatever comes through the cut is a separate question, and always has been. If you enjoyed this story, you can find the full article with images and sources at crazyalchemist.com. There is a whole library of pieces like this one on alchemy, esoteric history, myth, and the strange corners of science in 3 languages. If you want to hear more episodes like this, subscribe to the podcast wherever you are listening, and I will see you in the next one.
If you enjoyed today's episode, make sure to visit crazyalchemist.com for more intriguing content and follow Crazy Alchemist on Instagram and Facebook to stay connected.